I'm Professor Stotts, and I'm going to be talking in this video about a method that you can use to play computer, so to speak. It will help you understand how your program manipulates the memory inside your computer as it executes. So not only will this give you a better understanding of what you have been learning as we've been writing code in class, but it will also be a method that I would like for you to use when you're doing your evaluations so that I can see that you do have an understanding of what your program causes the computer to do. So what I'm going to do today is take the functions you see here in front of you, and we're going to execute them as if I am the computer. I'm going to show you a couple of bookkeeping methods by which you can keep track of which variables get created, when they get created, and how the values of those variables change as the program executes line by line. So let's get started. We have a program, as you can see here, a function called myMain. We've learned how to define functions and what that means. We have another function over here called fact. And so we have two functions, and we have this line right here, which you all know now, gets the ball rolling. So simply defining a function, as we have learned, doesn't do anything except teach the computer a definition to use if it is ever asked to use it. But here is the main activity here. This is a request for the computer to run the function called myMain, to begin executing. And so when we see this, we're acting like a computer. We see a couple of definitions, and then we see a request to actually execute. When we see something like this, we go and look up the function that is named, myMain, and we're going to create some space in memory where the variables defined in this function can be created, given their values, and manipulated. So let's begin. myMain is asked to be executed. So we go to the function myMain. In the computer, we're going to reserve some memory space, and I will draw memory space as a box like this. I will call this a memory map. Now, if any of you all go on further in computer science, you'll learn that that has other meanings. But for this class, we're going to call it a memory map because it shows me how memory is being used by this particular function. Up on top of the memory map, I'm going to put the name of the function that it is representing. And then inside, I'm going to carve off a little row for every variable that is involved in the function. So we see here, as we begin executing from top downward, here is the creation of a variable, and it is called max. And so I'm going to label one of my slots in the memory map max. I'm going to keep on going. The first thing I do is simply look through the entire piece of code, find all the variables that are created, and make sure I have a corresponding slot in the memory map for that variable. As we can see here, two are created, and there is no more creation of variables in that function, so I'm good with this. The next thing I do is go back to the top and begin executing again, but this time I'm going to start putting values into the variables that have been created. So the first line says, go to the variable max, put in a 4, so I'll do that. The next line does not put anything into the variable result. The third line says, I would like to go and call the function fact. I'm going to pass it the information that's stored in the variable max, and then I'm going to wait while this function runs. It will eventually generate some information and send it back to me, and this statement, result equals fact of max, says whatever comes back from the function fact is going to be put into the variable called result. Now this happens in JavaScript in a couple of steps, and so I'm going to draw a hidden variable, and I'm going to call it retval. It's not really part of your program that you wrote, but it's here inside of JavaScript anytime you call a function. So I'm just going to represent it like that. And then I'm going to do what it says. It says go and get the definition of the function fact. We're going to run that function. And so that means, as I said with myMain, anytime we run a function, we are going to create a memory map to represent that function. And so I'll draw another box to represent function fact. I'll label it as the memory belonging to function fact. And I'll do exactly what I did with myMain, except now I'm doing it with a different function. This memory map stays in existence because myMain is still executing. It's just kind of taking a break. It's waiting for this function to run and complete and generate some information. So I leave this memory map in the state that it was in. I'm going to use this one. I'm going to pass some information from my main into this memory map, compute something, and then pass some information from this map back to my main. And when I do that passing back, this memory map is going to go away because this function will have completed its execution. So let's go over here to function fact, and we'll take a little bit of a look at what happens in here. Where are the variables created? Well, we have to remember that n is a variable. It's a special kind of variable. We've called it a parameter of the function, but it's still a variable, and it still has to have space in the memory map so that its value can be stored. Second thing we see is we have a variable called I that is created. And thirdly, we see a variable called prod that is created. And so I'm just going to keep on, creating slots, giving them names until I have discovered that everything in the code that gets created is now represented in the memory map. And it is. These are the three variables that we have in function fact. The next thing I have to do is go back and start putting values into the variables and then executing according to the directions in the code. For a function call like this that has a parameter, the first value that I have to create is a value for the parameter. And that is where we connect the executing my main to the brand new fact. Over here it says when I call function fact, I'm going to look up the value of max in the memory map for my main, and I'm going to take that value and I'm going to copy it into the variable n in the function in the memory map for function fact. So I go back to my main, I look up the value of max, I discover it's a 4, and so I'm going to copy a 4 into the slot labeled n for function fact. And so to do that, I will just kind of draw a little arrow here that says we have some information being transferred from this memory location into this one, and so it's a copy. So that gives us an initial value for n, and now we can begin to execute through the code and see what happens to our other variables. I, nothing is put in it at this point. Prod does get the value of 1, so I'm going to put a 1 into prod. Next line says take a 1 and put it into I, so I'll put a 1 into I. Now we come to a while loop, and part of why I do this exercise is to help you understand what is going on, what a while loop causes the computer to do. We're going to execute through these two statements over and over and over until some condition becomes true, and at which point becomes false, and at which point we are going to stop executing the loop and then move on to the code that's at the bottom. Now you all have seen this. We've been writing that kind of code in class, and now I'm just making sure that you know what's going on with the variable values rather than just seeing the output coming out from your program. All right, so the first thing we do with a while loop is we go and we ask the question, is I less than or equal to n? The while loop says as long as I is less than or equal to n, I want to keep on executing the body of the loop. So is I less than or equal to n? We look up I, it's 1. We look up n, it's 4. Is 1 less than or equal to 4? Yes, it is. So that says we need to execute this loop body, come back and ask the question again. So executing the loop body says go and look up what's in prod, go and look up what's in I, multiply them together, and take that result and put it back into the variable called prod. 1 is in prod, 1 is in I, multiply them, I get a 1, and I put the result back into prod. And with this memory map technique, whenever I do an assignment and I do it a second time, what I want you to do is cross through the value that was there and write next to it the new value that's going to go into there. Now in this case it didn't change, but it did actually get done. The one that was there was overwritten with a brand new 1. So it didn't accomplish a whole lot, but this shows me that you understand that the variable value is being altered by the action of the program. So I want to see this happening, and that way I'll be able, when you're doing your evaluations, to tell that you are thinking correctly about the sequence of events that is going on inside the memory. The next step says I++. Now we know that's an idiom go to I and increment its value by 1. So that says change the 1 that's there to a 2. That's the end of our loop body, so now we go back and we ask this question again. Look up I, look up n, is I less than or equal to n? Well, I has a value of 2, n has 4. Is 2 less than or equal to 4? Yes, it is. So I'm going to do the loop body yet again. Look up prod, look up I, multiply it, take the new value, put it back into prod. Prod has a 1, I has a 2, multiply it, get a 2, put the 2 back into prod. I++, go to I, increment its value. Go back up here and ask the question again. Is I, which is 3, less than or equal to 4? Yes, it is. So I'm going to do the body yet again. Go to prod, 2, multiply it by I, 3, that's a 6. Put the result back into prod. Increment the value of I. Go back and ask the question again. Is I, 4, less than or equal to n? 4. Yes, 4 is less than or equal to 4. So we're going to do this loop one more time. Prod times I, 6 times 4, that's a 24. Put the result into prod. I++, 4 becomes a 5. Go back and ask the question again. Is I, 5, less than or equal to n, 4? No, it's not. So this is the first time in executing the loop that this question has come up false. And that means the loop is done. We are not going to execute the body again. Instead, we're going to go to the closing brace and begin executing whatever code follows the body of that loop. The only thing left in this function is to do a return statement, and a return statement is where we take some information in the memory map for the function we called, and we transfer that information back to the memory map for the function that called it. Now this says, go get the value that's stored in prod, send it back to my main. And now that's where this little magical invisible retval variable comes in. I'm going to go to prod. Its current value is a 24. Return says, take that value 24 and stick it in this hidden location back in the other memory map. And so we're going to do this, and we now have a 24 sitting here in the return location. The return statement also functions in our execution to say that this is done and we no longer need the memory map that we were using to execute that program. Now I'm going to kind of leave the memory map here because I can see the history of what was done with those variables in coming up with this 24. But I'm just going to draw a little X through it to kind of indicate that it really doesn't exist anymore. Once we do a return statement, the memory that was used to compute the value of that function is no longer active, it's no longer available. It, for all practical purposes, vanishes from your program. The function is still here, but this particular piece of bookkeeping from asking that function to run has been used and is gone. So now we're back over here. We're at this point. Fact has been called. It was executed. It was executed on this value max. And it has now produced a value which is sitting over here in retval. And so the rest of this statement right here says, go get the value that comes back from that function and put it into the variable called result in the memory map for my main. So we take the 24 that's here and assign it to the variable result. That completes this line. And then the last line simply says, go look up the value that's stored in result, print it out, and so that's where we're going to get our answer from. And so we see that result contains a 24, and so the final result, if I were to ask you what happens, what gets printed out when this program is executed, then the answer is a 24 is printed out. So that summarizes at least our introduction to this notion of using memory maps to help you symbolically execute your code and understand what's going on inside the computer.